Okay, start. Yeah, good evening children. Right. In our previous class we have discussed about the integers, am I right? And its properties also. Once revise, quick revise. What are the properties? Additive inverse, multiplicative inverse. Am I right? We are not discussing multiplicative inverse. Only additive inverse and identity property both. Additive identity, multiplicative identity. What is the additive identity for every number? 0. Multiplicative identity is 1. Okay, na? And we discussed about that even number also. The number which is exactly divisible by 2. Exactly means divisible by means without leaving any remainder. Okay, na? Odd number means leaves the remainder 1. Odd number, a number which is divisible by 2 leaves the remainder 1. Am I right? Leaves the remainder 1 are called odd numbers. Example 1, 3, 5, 7, 9 and so on. So least or smallest odd number is 1. Largest odd number cannot be determined. Same way, least even number 2, largest even number is cannot be determined. Okay, now until then? Yeah. And you already learned about the predecessor and successor. Predecessor, successor. Predecessor means the number which is exactly before the given number. So nothing but -1. For example, predecessor of 5 is 4. 5 minus 1, 4. Successor of 5 is 6. Successor means immediately after number. This is only work out for integers, okay? Predecessor for 5, exactly before 5 is 4. That means 5 minus 1, 4. This is 5 plus 1, 6. Successor after number. Okay, now? Now I am taking the set of natural numbers. Natural numbers means nothing but counting numbers, right? Natural numbers are nothing but counting numbers. So 1, 2, 3, 4 and so on. What is the predecessor of 1? Predecessor of 1. Is there any number before 1? No. So there is no predecessor. In the set of natural numbers I am talking about, not integers. For natural number there is no predecessor. Successor of 1 is 2. Successor of 2 is 3. 3 successor 4. 4 successor 5 like that. Okay, na? Now I am taking the whole numbers. Whole numbers means 0, 1, 2, 3, 4 and so on. Now predecessor of 1 is 1 before we have already number in the set of whole numbers 0. But 0 predecessor not there. Okay? If you take integers and so on, -4, -3, -2, -1, 0, 1, 2, 3, 4. For every number we have both predecessor and successor in the set of integers. 0 predecessor -1, -1 predecessor -2, its predecessor -3, its predecessor -4, like that we go. So in the set of integers we have for every number predecessor and successor also. But in the natural numbers we don't have a predecessor of 1 because 1 before there are no numbers in the set of natural numbers. And whole numbers starting from 0, predecessor of 1 is 0, predecessor of 0 not there. Okay, na? So successor or predecessor, immediately after number, immediately before number. Before number means predecessor. Pre means before. Successor after. Clear children? Yeah. So just write odd numbers. A number which is exactly divisible, which is divisible by 2 leaves remainder 1. When a number is divided by 2 leaves the remainder 1 is called odd number. Exactly divides, that means without leaving the remainder, is called even numbers when we divide with 2. Okay, now predecessor or successor. How the predecessor for natural numbers, how the predecessor for how the successor for natural numbers, like that. Clear? Good. Next. Please note it, children. Please note it. Yeah, finish writing, children. Okay, next. Next we should discuss about that prime numbers, composite numbers. Prime numbers, composite numbers. So before that, let us see what are multiple, what is multiple, what is factor, what is multiple and what is factor. Okay, children. So multiples are simply we can remember by taking an example for a tables. For example, 3 tables is there. So 3 ones are 3, 2s are 6, 3s are 9, 12, 15. These are all are coming in the table of 3. So these are all the multiples of 3. Okay, na? Multiples of 3. Now for example, now I am taking the example for factor. Factor means if I take 15 I can write as 3 5s are 15. 3 5s are 15. Here 3 and 5 are factors of each other. Factors of each other. Means factors of 15 each. Actually, they are the factors of 15. And 15 is the multiple of both of them. 15 is the multiple of both of them. Okay, let me write one example here. Say multiples I am writing in the form of table. 3 ones are 3, 3 2 6, 3 3s 9, yeah, 3 4s are 12. Now 3 6 9 12. These are all coming in 3 table, right? These are the multiples of 3. These are the multiples of 3. Now if I take any one of them here, say 6, 3 2s 6. So 3 and 2 are factors. 3 and 2 are factors of what? Factors of 6. For 12, 3 4s are 12. 3 and 4 are factors of 12. 3 and 4 are factors of 12. Okay, now? Got it? So multiples can be remembered easily with the table. Factors means, for example, in a table if you take 6, 3 to 6 is multiple of 3 and 2. That means 6 will come in 3 table, 2 table also. 6 is multiple of both 3 and 2. And 3 and 2 are factors of 6. Reverse. 3 and 2 are factors of 6. Okay, now? Yeah. Now let us see one example, children. Now I am taking 56, okay? Or find factors of 24. Let us take 24 will come in how many tables? Always every number will come in one table. 124s are 24. 2 table 24 will come? Yeah. 2 table 12 times. 2 12s are 24. 3 table will come? 3 table. 3 8s are 24. 4 table? Yes, 4 table also will come. 4 6s are 24. 5 table? 5 table 25 won't come. 5 4s 20, 5 5s 25. 5 table 24 won't come. 6 table 6 4s 24. See 4 6 0, 6 4 0, both are same. So it is repeated now. We stopped here. So therefore 1, 2, 3, 4, 6, 8, 12, 24. In all the tables we are getting the number 24. One table we are getting 24, two table 24 will come, three table, four table, six table. These are all factors of 24. These are all factors of 24. Okay, now? So we have to check up to how I am stopping here. 4 table 4 6 are 24. 5 table 24 is not coming. 6 table here. If you write 6 table 6 fours, 6 fours 24. Same repeating. 4 into 6, 6 into 4 both are same. No, now I can erase this. So up to here I am taking all 1, 2, 3, 4, 6, 8, 12, 24. These are all factors of 24. Okay, now? Now you find the answer for 56 children. Okay, 30. Find the factors of 30. Try this one. Find the factors of 30. Yeah, find the factors of 30. Yeah, table wise. Every number will come in one table. Yeah, 130 is 30. 2 table. Yes. 2 table in 30, 15 times. 2 15s. 3 table. 3 times are 30. 4 table. 4 table 30 will come. No. 5 table. Yes. 5 table 5 6 are 30. 6 table 6 5 are 30. See 5 6 are 6 5 are 30. It is repeating. So we can delete this. Therefore the factors are 1, 2, 3, 5, 6, 10, 15, 30 are factors of 30. Here in the set of factors we got 30 also. That means every number itself a factor. Every number itself a factor. One is common factor. One is common factor. Okay, na? Got it? So multiples of factors. Here 30 is multiples of these all numbers. These all numbers are factors of 30. Clear, children? Yeah. Next. So even number, odd number, multiple factors. We completed. Now very important one is prime numbers. What are the children? Yeah, prime numbers. Now you know about the factor. That means actually the definition of factor is when two numbers are multiply each other. Two numbers are multiply each other. Each of the number is factor to the product. Each of the number is factor to the product. 7 5 is 35. Here two numbers are multiplying each other. Each of the number is factor to the product. That means 7 is factor to the 35, 5 is factor to the 35. Each of the number is factored to the product. Now, prime number means a number having exactly two factors. Prime number means a number having exactly two factors. That means only two factors, not more than that. Not more than two factors. Number having exactly bracket lo only two factors. Numbers having exactly two factors are called prime numbers. Are called prime numbers. Okay? Examples. 2 is a prime number because 2 is coming in 1 2s are 2. It won't come in any other table. Here 1 is a factor, itself is a factor, 1 and itself. 2 won't come in any other table. So only two factors, so 2 is prime number. But what about 1? 1 ones are 1. 1 won't come in any other table. Alright? So only one factor. To becoming a prime number, we have only two factors, not less than, not more than. So 1 is not a prime number. So 2 is a prime number. Next 3. Yeah, 3 also will come in only one table. 1 3s are 3. 3 1s, 1 3s both are same. Here 1 and 3 are factors of 3. What about 4? 1 4s. 2 2s also 4. So 1 4 2. 3 factors having. So 4 is not a prime number. Now 5. 5 table will come in 1 5s. Yes. 5 is a prime number. Now 6. 6 will come in one table. 2 3s are 6. So 1 no, 6 2 3. 4 factors. So 6 is not a prime number. Okay, now you can check remaining numbers like that. 7 is a prime number, 11, 13, 17, 19, 23, 29, like that. These are all prime numbers because they are only having exactly two factors. Exactly two factors. Okay, na? Got it? Yeah, remaining numbers will get more than two factors. So they are not prime numbers. 1 is also having less than two factors. But I am saying that only two factors are called prime numbers. Now while you are finding this, there are 25 prime numbers. From 1 to 100, there are 25 prime numbers. Okay, now same like 100 to 200, there are 21 prime numbers. 1 to 100, I said 25 prime numbers. You should find what are the prime numbers. You check like that. Definition is only two factors. I am saying that how 4 is not a prime number, how 6 is not a prime number, like that you check. Okay, na? You have to tell remaining prime numbers from 1 to 100. So until how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I said 10 prime numbers until then. So out of 25, if you remove 10, still we have 15 prime numbers. Those 15 prime numbers you have to check and show me the answer in next. multiply each other. Each of the number is factor to the product. Factor to the product. Example 8 9s are 72. Therefore 8 comma 9 are factors of 72. Both 8 and 9 are factors of 72. After that, write prime number definition and find the prime numbers from 1 to 100. Okay, na? Check that. Yeah, okay, children. Now let us discuss one more concept, composite numbers. I am erasing this. Yeah, composite numbers. Until then we discussed about that prime numbers, right? Now composite numbers. Composite numbers. Composite numbers means the numbers having more than two factors. Numbers having more than two factors. Exactly two factors prime number. More than two factors composite number are called. Okay, na? The numbers having more than two factors are called composite numbers. So 1 to 100 I said 25 prime numbers, except one remaining all composite numbers only. Except one from the set of prime numbers, if we delete one is separate, which is neither prime nor composite. So we can take out one, remaining all numbers are composite numbers. Write this definition and example. Yeah, first composite number is 4 because 2 is a prime number, 3 is a prime number, 1 is neither prime nor composite. First composite number 4, 6, 8, 10, sorry 9 also, 10, 12, 14, 15, etc. These are all composite numbers. Okay, children? Yeah, please note it. And once revise the concept, children. Okay, children. So, what are the topics we discussed today? Odd numbers, predecessor, successor, next multiples, factors, then prime numbers, now composite numbers. Okay, now your task is write all the prime numbers from 1 to 100. Okay, nothing but prime numbers means exactly 2 factors, means only 2 factors. Okay, yeah. So that is for today, guys. So we'll meet in next class, next maths class. Okay, thank you, Ananta.